you be presented to make you do everything because you're right in front. You have to. It's very minor thing. Just saves me from having to type. Okay, let's get your homework out. Let's get your homework out. Let's take a look at some things and give you an opportunity to ask some questions. I just started the class, so no, I didn't.
It's taking forever to turn on.
Yeah, well, I'm not plugged in, so it'll probably take a little while. All right. So you're gone yesterday. Hopefully you got a chance to see the video, but we talked about our gateway test that is going to be next Tuesday. The gateway test, 10 derivative problems, 10 problems where you just have to find y prime, f prime, whatever, and you have to get 8 out of 10 right. You have to get 8 out of 10 right, and if you don't, you have to come in on your own time, free period before school, after school lunch, to keep taking it until you get 8 out of 10. Okay? And your grade is based on how many times it takes you to do it. Right? So 30 out of 30, if you pass it the first time, pass it just means 8, 9, or 10, doesn't matter. You get 2 more tries after that to get 27 out of 30. Those have to be within about a 3-day window. I didn't say this the other day because I've had people do this where they don't pass the first time and then they wait, and then 3 days before Christmas they take the second one. Well, by then you don't have the opportunity to get 27 out of 30, right? It's got to be within that next 3 to 4 days, and then it drops to 24 out of 30. So you need to. So it's based on how many tries it takes you and the timeliness of your attempts as well. Plus, think about it. We're going to be moving on Wednesday to new stuff. So it really, really is important for you to put a bunch of time in this week and weekend leading to next Tuesday practicing these derivatives. Okay? Because that's the only time where that's what our focus is going to be. After next Tuesday's gateway test, we're moving on to new stuff. So you'll have homework and new things to learn, and we'll have another quiz right before break on that Thursday. It's not a semester test or anything, it's just going to be a normal quiz. But it is, and then we have the Calculus Carol extra credit opportunity on that Friday, that last day. So we'll have a quiz on that Thursday, though, before that. So we'll be working on new stuff heading up to then for that last week. So, the more work you put in leading up to there, then if you don't pass it, you just have to brush up on a few things, correct a few errors, maybe you'll pass it on the next couple. But if you're trying to relearn everything and stay up with the new stuff we have, then it gets pretty tough. Okay? So that's why, this week is so important to work on this. All right. So if I just put number 11 up here. Now, probably not really necessary because we did. Okay, why haven't you? Okay, yesterday we talked about this. So on number 11, you're supposed to work this 2 different ways. One with the product rule, one with just using your algebra. So here, one way we can do this is we can add the powers. So 1/2. Now, one of the things you will have to do on this next quiz, you probably have to do some work with fractions. So you're going to have to brush up on that. 1/3 would be 2/6. So 3/6 plus 2/6, we add the powers, we get x to the 5/6. We want to do the derivative of that. We just bring the 5/6 down in front, subtract the power by 1, we get negative 1/6. But now we learned this new thing yesterday called the product rule. The product rule says that we can treat that as our u and that as our v. We can do the derivative of the first, the product rule, u prime v plus uv prime. So the derivative of the first would be this. Leave the second one alone, plus the first one left alone times the derivative of the second, which is this. Now we can go ahead and do some algebra with that. We can multiply those together, which means we can add their powers. That'd be negative 3/6 plus 2/6. That'd be negative 1/6. Here we got 1/2, which would be 3/6, and negative 2/3 would be negative 4/6. So 3/6 plus negative 4/6 would be negative 1/6 also. Oh, nice. They're like terms. They have the same power. So we can add them together. 1/2 would be 3/6. 1/3 would be 2/6. 3/6 plus 2/6 is 5/6. And we notice we get the same thing. Do not confuse this with the T chart, right? That's not what we're doing here. I know it looks like a T, right? This is not a differential equation. We're not doing that. We just worked it two different ways, right? A and B. We worked it two different ways, and we saw, hey, we got the same answer when we did the derivative. Okay? All right. What else? I've got 43 up here, so what do you want to see between 11 and 43? Speak now. Maddie? 19. Tell me what the function is.
Yes. 1 minus x cubed.
What's it called? H of x equals what?
1 minus x cubed.
That's it? 1 minus x cubed?
Over
Okay, there you go. Over, so 1 minus x cubed over.
1 minus x.
And did it say to work it two ways?
Yeah.
Is that what the problem is, the working it in two ways? Is that the question, or just the quotient rule? Here's why I say this. Because the algebra, I would not expect you to do one of these. As a matter of fact, on the gateway test, you're never going to have to do what we're doing right now, work it two ways, right? You're not going to. You would just do a quotient rule on this one. But sometimes there's some algebra where you could simplify it, right? Like on this last one, you would never do the product rule on this one, I don't think, right? You would just multiply that together, and then it would be better to simplify. Okay, this one can be simplified, but you have to remember Mrs. Andreessen's, if you took Honors Algebra 2, rule for difference of cubes. And if you did not remember that, then that would make that very difficult. Difference of cubes, factors like this. That's how a cubed minus b cubed would factor. So the top could factor into 1 minus x times 1 plus x squared, and then the 1 minus x's could cancel, and then this would simplify to that, and now the derivative of that would be what?
2x plus
1. Or I'll just, yeah. Well, yeah, you're right. 2x plus 1. I'll just go in the order, though. So the derivative of 1 is 0. Derivative of x is 1. Derivative of x squared is 2x. So that's how you would work at the algebra way. You will not have to memorize that or do that with that difference. So don't worry about that. I'm sorry. I forgot that was on there. And I would have given you that factoring thing ahead of time. Okay? Let's do the quotient rule. That'll be good practice. So the quotient rule is u prime v minus uv prime all over v squared. Now, if you have trouble remembering that, you could learn it the way my calculus teacher taught me. Instead of u over v, he taught it as high over ho. High is the one up high, and ho is the one down low. The derivative, here's how he taught us. You do the u prime v, so you do the bottom left alone times the derivative of the top, which he wrote d high. Derivative of high, right? So that'd be ho times the derivative of high. The bottom, the v times it, so I flip those. Minus the top left alone times the derivative of the bottom. Over the bottom square. Ho-D high minus high-D ho over ho-ho. That's how I learned. I used to teach it that way, and nobody thought it was nearly as much fun as I did, so I quit. I quit teaching it that way. But if you want to remember that, Ho-D high minus high-D ho over ho-ho. Okay? But mostly we'll just stick with that. Okay? All right. So anyway, derivative of the top would be negative 3x squared. Now, I'm pretty liberal with use of parentheses here because lack of parentheses can really get you in trouble here. Okay, so there's the u prime, derivative of the top. The bottom left alone is 1 minus x. Right? Minus, and this is why they really get us in trouble, because of that minus. U is just the top, so I've got to have parentheses around that. This single thing probably causes more people to fail the gateway test than any other thing. Obviously, not knowing the rules is going to make you fail the gateway test. But aside from that, lack of parentheses, losing a sign, something like that is the other thing that's going to cause you grief. Okay, what's the derivative of the bottom? Negative 1, right? Okay, all over the bottom square. yesterday we said that there's a certain amount of simplifying you have to do. Now, in the quotient rule, the simplifying would come from combining some stuff on the top, combining things together, and maybe something could factor and then cancel, possibly. Okay? So that's what I'm going to do. So on top, let me change the blue here. So on top, I can distribute there. Again, always think of the top as two parts. There's this part and there's this part, right? Order of operations, multiplication comes before subtraction. So those two things, it's like there's two terms up there. You have to treat it that way. So in this first term, I'm going to do this. So I'm going to get negative 3x squared plus 3x cubed. Then I've got minus, and now I've got this other thing. Now I'm going to leave that in parentheses here because that, again, gets us in a lot of trouble. I'm going to take this negative 1 there. Now, could I just take that negative 1 around with this negative and make it a positive? That'd probably be smart. Matter of fact, I'm going to do that right now. So the negative 1 around front with that negative is going to turn that to a positive, and then this will just be 1 minus x cubed. Sometimes it's not quite that easy, though. Okay, so you got to be careful with that. Okay, and since it turned to a positive, I don't really have to worry about those parentheses. Okay, now we got 1 minus x quantity squared. Now on top, we have negative 3x squared. 3x cubed minus that would be what? 2x cubed plus 1 all over 1 minus x quantity squared. Now, I could rearrange, but I told you rearranging is not important. Now, is that the same as that? Well, evidently, if you divide this into this, it does come out to be that, but there's no earthly reason why I'm going to make you do that algebra for that. Mrs. Andreessen, you did some of that. You did long division with polynomials back in Allender's Algebra 2. This would be a great time to do that. Some college professors will love to make you do this, okay? And then when you're doing it, your college professor's making you do it, you can sit there and think what a great guy Mr. Clark was because he didn't make us do this, okay? But anyway, on the gateway test, if you do the quotient rule and you get it down to there, you're good. Because there's no basic factoring I can do on that top to make that happen. Okay? Now my guess is if you type this into your calculator, which Emily, did you get logged in?
Yep.
Okay. So let's go ahead and do this on the calculator real quick. So just go ahead and do your derivative. Now everybody, if you were gone yesterday, remember that's by the 9 here. Okay? And so we can grab that. Put an x down here, do our fraction, put 1 minus x cubed on top. Now, what I'm going to show you here is what I was talking, and then 1 minus x on the bottom. Now, what I want to do next is I want to show you, go ahead and hit enter, and we get 2x plus 1, right? The calculator did that simplifying. Now, I'm not sure what that little warning symbol is, but it has to do with domain issues probably. X can't be a 1, probably. X can't be a 1, otherwise that would be undefined, right? So I think that's probably what that's meaning. But anyway, one of the things I said is when you're practicing for this gateway test, how do you know you're doing them right? So on this one, that's why I say your calculator can be a great tool to see if you're doing them right. But now in this one, you might have an issue because you would do this problem with the quotient rule and you'd get this, you go, oh my God. I did horribly. I got something that's not even close to that. Well, what you want to do is you want to type this in to your calculator. And so have the calculator do the derivative, and then take your answer and type it in. So let's go ahead and do it. It was negative 3x squared plus 2x cubed plus 1.
If I do that,
Whoops.
oh, no.
It's okay. Just hit delete.
Delete all of it?
No.
Oh.
Just right there. And then hit your right here. There you go. Plus 1. Now, you didn't do the fraction earlier, right? So hit a right parenthesis. There you go. And now it divides. Just hit divides. And then and now it parenthesis. Was it 1 minus x? Quantity squared. So 1 minus x, and then outside of that, a square. Okay? All right.
Something happened.
Macy knows.
Okay.
Wait, when you distributed your negative,
Well, I didn't distribute the negative 1, actually. What we did is we took the negative 1 No, I know what happened here. I took this, I didn't distribute it actually. I took the -1 around front and made it positive with that. But here's what she did wrong. This is what Emily did. God, Emily.
So sorry.
She did the derivative of our answer,
Yeah, what do you?
right? Which would be like the second derivative. Well, what is a derivative of 2x plus 1? 2, right? So what we want to do is just take off the derivative. So arrow up there, hit enter,
Go over.
and then just go over and just delete.
Oh. I'm sorry, I don't know.
I don't know either.
Just go to like, do the derivative of the
Yeah, this right there, hit delete.
No.
Okay.
That's what you told me to do.
Do this.
Maybe like highlight things.
We can highlight,
Okay.
hit the right arrow. Okay, now hit shift. Hold down the shift and then right arrow, or left arrow. Hold down the shift and up.
You're
Yeah.
right, I messed it up. Okay.
There you go, right there. Now hit Control C for copy. Now hit enter. Okay, syntax. Oh, okay. Just hit delete. Just hit delete. Delete the whole thing. There you go. Now Control V for paste. Okay, so now let's talk about what happened because this is a common error. Okay, what we're trying to do is we're trying to compare our answer to see if it's the same as 2x plus 1. So what she wants to do is just type her answer in, not do the derivative of her answer because that'd be the derivative again, right? Just type your answer in, hit enter, and it should simplify it the same way it simplified that derivative. So it's 2x plus 1. So there we go. We know we did it. Now the other thing you could do is go up and grab your answer. I think I showed you this the other day. Grab that. Just grab it.
This one?
No, the other one. Where grab that, hit enter. Then hit equals, and then type 2x plus 1. And our question, now this is like saying, is that first one equal to 2x plus 1? Hit enter, and then what it'll say is it'll say true. And so then that's the other thing you can do. So you can type in your answer compared to what the calculator answer was, and it'll tell you if they're the same. Okay? Same thing, you can do that with the back of the book answers too, if you're looking in the back of the books. Okay? All right. Another one. Another one. Is there any others before number 43? Lauren?
31.
31? What's 31 say?
X, quantity of
What's the function?
f of x
Okay?
equals the quantity of x plus 1 squared over x squared plus 1.
Okay? So the quotient rule says u prime v minus uv prime all over v squared. So we do the derivative of the top, which would be bring a 2 down in front. This is f prime now. We bring a 2 down in front, leave the inside alone, and we drop that to a 1. Is there anything multiplying on the inside we have to kick out? No. So that's the u prime part. Now we got to times that by the bottom, which would be x squared plus 1. Minus, now we need the u part, which is just the top, so that's x plus 1 squared, times the v prime, which is the derivative of the bottom, which is 2x. Notice how I put parentheses around each of those things. All over the bottom squared. Okay? That's your first step. Now, oftentimes you can stop there. Now, especially if it's sines and cosines and stuff like that. But if it's just algebra type stuff, then it usually amounts to go ahead and multiply this out and see if some nice things will happen. So we do get into a little bit of FOIL. You're not going to have a lot of this on the gateway test, right? There's going to be a mixture of easy, medium, hard. I would put this more in the medium category probably because at least by the time we take the test, right now it's harder because we're just learning it. But by the time we get to next Tuesday, this will be more medium. But there is some algebra here. So if we FOILed this, I'm going to put this 2 through this one, 2x plus 2, just to make it a little easier on my FOIL. So I'm going to FOIL that. I get 2x cubed. Outers would be 2x. Inners would be 2x squared. Last times the last would be plus 2. I got a minus. Now I'm going to need some parentheses here. So now this is going to be x squared plus 2x plus 1, right? When I FOIL that, and then times my 2x, I'm going to distribute that 2x. So that's going to be 2x cubed plus 4x squared plus 2x, correct? Now I'm going to distribute this negative through here, so this is going to turn into negative negative, and negative. Now I can make that a plus. Everybody see what I just did there? Right? It was minus that whole thing over there. So I put it plus and did everything opposite in there. And then, of course, don't forget I got this whole bottom. Sometimes that's another thing people run into is they get so caught up messing with the top and getting that all done, they forget there's a bottom squared, a b squared down there. Okay, what do I got? The x cubes are going to go. The x's are going to go. I get negative 2x squared plus 2.
Isn't it?
Right?
Yeah.
So, and then x squared plus 1 squared. Now, it almost looks like it could take out a negative 2. But unfortunately, when I do that, I get x squared minus 1, right? I was hoping maybe something would cancel there. But it doesn't look like it does. So there we go. I don't know, does the back have that or something else? Or?
Yeah.
It basically has that. Okay. So there you go. So that is a simplified version by foiling and combining on top. Because the reason you do that is you're hoping then that maybe you'll end up with something that you cancel off that you don't. But you do need to simplify down to there. So you can see there's an algebra component to this that is important. Okay? There's definitely an algebra component that's important. Okay? All right. All right, let's move along here, and then we'll see if there is some other questions at the end. Some more questions on some of these, we can talk about them if we have some time. Okay, I wanted to go through 43 here just a little bit. So this was that other thing we talked about. They wanted to find h prime of 2. They wanted to find h prime of 4. I just want to reiterate, before you can find h prime of 2, you have to find h prime of x. Before you can find h prime of 4, you have to find h prime of x. So you have a place to plug the 2 and a place to plug the 4. So this is a product rule. So the product rule says derivative of the first, leave the f alone, leave the first one alone, and then the derivative of the second, which is f prime. Now you have h prime of x. Now you can plug a 2 in. You plug a 2 everywhere you see an x. So 2 times f of 2 plus 2 squared times f prime of 2. Now, is this one they gave you a graph? They gave you an f graph?
Yeah.
Okay. And so now 2 times 2 is 4. You look up f of 2 on the f graph, and it's negative 4. So that gives you negative 16 on this first piece. And then you look at the slope. I think it's right down there at the minimum, right? So at the minimum, the slope would be 0. And so you get 0, you get negative 16. When you put your 4 in there, however, the slope at 4 you have to estimate. So the slope at 4, f prime of 4, I put 4 there. You might have something a little different. So in this case, I've got approximately 64 is my answer. Okay? That's assuming you read the slope to be 4. But again, that's where you draw in a little tangent line and see. Now that's not going to be on the gateway test. But while we're working towards the gateway test this week, we're going to be doing some other stuff too. I mean, our goal then as we go into chapter 4 is we can use these derivatives we're finding to solve other problems, right? So we still want to remind ourselves of the chart and all those kind of things that the derivative tells us, okay? But our main focus right now is being able to find the derivative. Because if we can't do that, then we can't do any of the rest of it. Okay, questions there? All right. Then they ask about something you needed the second derivative. What was this? Is this number 46 maybe or 45? Okay, so you just have to do it again. So you have 2 product rules to do. So the derivative of 2x is 2. Now, that brings up another thing. Somebody had asked what happened in the other class. They said, what if you have 3 things multiplied? Well, what you do is you group 2 of them together and think of it as one thing. So if I have 2x here, I'm not going to think of that as 2 times x times f of x, 3 things. I'm going to think of the 2x as one thing. Does that make sense? So the 2x is one thing. All right, so the derivative of 2x is 2. Leave that alone. Leave the 2x alone. Derivative of f is that. Then you move on to this one. Derivative of x squared is 2x. Leave the f prime alone. Then leave the x squared alone. And derivative of f prime is f double prime. So now that would be, as you go through this, now you put your negative 1/2 in here everywhere. The problem becomes, what is f double prime of negative 1/2? Right? So I went through here and I plugged all these numbers in and I got all this stuff. Well, what was the question on 45?
Is H concave?
Is H concave up? Well, the answer to that is yes, if H double prime is positive. So the question really is H double prime positive? Well, look what I have so far. I got 5 plus 4, which is 9, plus 4 is 13. I got 13 plus whatever this last piece comes up to be. Well, I've got a positive number here. And what do you notice about the F graph all the time? The F graph all the time. Isn't this the F graph on that problem? It's a parabola. It's always what? Concave up. It's always concave up, the F graph, right? So what's that tell you about F double prime? It's always positive. So I don't know what F double prime of negative 0.5 is, but I know it's positive. So I'm going to have 0.25 times some positive, so I know this is going to be positive. So I'm going to have 13 plus some positive, so clearly it's going to be positive. So H double prime is going to be positive, so yes, H is concave up. Good? All right. And then I think on 46, is it, they tell you F double prime of 2 or something, right? So you would go through the same process, but you plug 2 in everywhere, and at the end, they tell you what F double prime of 2 is, so you can just substitute the number. Okay? All right, so that's just some more doing that. 48, I don't want to talk a lot about this one because it's really the same thing. The key is this step right here. Here's what your M prime would look like, right? Following your quotient rule. The derivative at the top is F prime, leave the bottom alone. Minus the top left alone, derivative at the bottom is 2x. Bottom all squared. Now you plug in your 3 everywhere, and we get all these numbers, and I end up with a positive number. So since M prime is positive, M has to be increased. Isn't that what it asked? Right? So that's the kind of stuff that is happening here. Okay, where we can use these kind of things. But I do want to focus on our new rule here today and getting the practice in doing these. Okay, here was 79. This is the last one I wanted to take a look at. And Gabe, read me what number 79 says there. Oh, Brianna, read me what number 79 is.
Let f of x equal e to the x cosine x,
Okay,
at which values of x comparable 0 to pi does f a achieve its maximum value, b achieve its minimum value, or c have an inflection point.
okay, so global max and min, right? So think back to the quiz we just talked about, list of candidates. Where can global max and mins be? At the stationary points and at the end points. Yeah, I thought I said it. No, I said stationary points, right. Stationary points and end points. So we need to do the derivative and set it equal to 0. So this is just an example of what, now that we learn these rules, how we can now put that to work with the same stuff we just did on a quiz at the end of chapter 2. So we would do our product rule. So derivative of e to the x is e to the x, leave the cosine alone. Then the e to the x left alone, and then the derivative of cosine is negative sine, so I stuck the negative in front there. Okay? And then I got to set that equal to 0. Now, let's assume this is no calculator right now, right? Everything at this point is no calculator. So we're going to pull out an e to the x on this thing, and we're going to end up with cosine minus sine, right? And then either that is 0 or that is 0, right? So where does e to the x equal 0? Never. E to the x looks like this. E to the x is never 0, so we don't have to worry about that. Where does cosine minus sine equal 0? Well, where cosine equals sine. Between 0 and pi, which is just the top half of the unit circle, where does the cosine and the sine values equal each other? At pi fourths. Would it be over here at 3 pi fourths? No, because cosine would be negative there, and sine would be positive, right? They would not be equal, okay? It's only at pi fourths and 5 pi fourths where that happens, right? But they only want us to look from 0 to pi. So, x equals pi fourths is our only solution. So that is one we would need to be able to solve, okay, without our calculator. So there's only one stationary point. So our list of candidates would be those three places, our endpoints and our stationary points, okay? And then we would plug those back into the original. So e to the 0 is 1, cosine of 0 is also 1. Put in a pi, e to the pi, who knows what that is? Some number. Cosine of pi is -1. So this would be negative e to the pi. Now remember, e is 2.7 something, and pi is 3.4, so it's 2.7 raised to the 3 something. So negative something. Well, 2 to the third would be -8, but it's 2.7. 3 to the third is 27, so it's somewhere in there. -20 something maybe, okay? But I don't think we'll have to get that accurate, to be honest with you. Pi fourths, so now you got e to the pi fourths. And then cosine of pi fourths is, what, root 2 over 2? Oh, that's ugly. But it's positive, right? So it's going to be greater than 1, right? Root 2 over 2 is like 0.7. E to the pi fourths would be 2 point something to the, I think it's going to be greater than 1, okay? But I'm not going to ask you to have to try to figure that out, okay? But definitely, it's not in the gateway test at all, right? The gateway test is simply derivative problem, okay? But later on, it'll be, we'll have numbers a little easier, right? Here at the end, then I might say, hey, use your calculator, whatever. Now, the other thing you can do, a number, we'll get into this later on, so I don't want to make a big deal about it right now. But here's where it wouldn't hurt to do a number with your pi fours. Because then you can tell if the function's increasing and decreasing, and then that kind of helps you tell about this number. But clearly your minimum value is there because it's negative. And then our max value is either between this and this, right? And so, but I think what happens is this function's increasing then decreasing. So it's happening at 0, we get a value of 1, then it increases until pi 4, so this value is going to be bigger than 1, and then it's going to decrease down to there. Okay, so this is going to be the max. So that's just that list of candidates. The inflection point, you just do the derivative again. Okay, and it ends up being a very similar argument, but you get more practice here on product rule because you got to do it twice, just like that problem we saw. I don't want to get into that right now because that's a repeat of some stuff we've done. But inflection point, remember, just set derivative, set equal to 0, put it on number line. Okay. But our main focus here now is just doing our derivative. Okay. Any question about just product rule or quotient rule in general? We're going to have plenty of practice over the next days here, having some of those doing it. Okay. So if you got the basics of doing it, you know, that's pretty good at this point. Okay. Okay, perfect. All right, so let's, our presenter now is going to type in for us the derivative of sine of x cubed. Now, if we were going to guess the derivative, we would probably say what? We'd probably say cosine. What would we do at the inside? Wouldn't you leave it? Haven't we always said the inside doesn't change? And then we also talked about kicking out something. Now the problem is, what did we always kick out? Whatever number, whatever the coefficient was in there. Is there any coefficient? No. So is there anything to kick out? Doesn't seem like there would be. Well, Emily is going to do the derivative for us. Go ahead and hit the button, Emily. Huh. What did it kick out? Interesting. So, when we've been kicking out a 2 here, isn't 2 the derivative of 2x?
Yeah.
Or if this was 2x plus 1, we didn't care about the plus 1, we just kicked out the 2. Well, what's the derivative of 2x plus 1? 2. I have never given you one up until now that had anything on the inside other than a plain old x to the first, right? never giving you an x squared, never giving you e to the x, never giving you anything else on the inside other than a plain old x to the first with maybe a number in front. And we said you just kick out that number. Now why? Because we said that squeezed the graph, so it made the slope steeper. But we don't have to worry about that anymore. We don't have to worry about when we kick it out because it made it steeper and did that stuff. We don't have to worry about that. We've got a new rule. We just have seen that if there's something on the inside, all we do, we leave it alone. We do the derivative of the outside, like sine, do the derivative of cosine. What we kick out is not just the number that was in front. Actually, what we're doing is we're kicking out the derivative of the inside. And that is exactly what we do. And so we would kick out a 3x squared because that's a derivative of the inside. And this is probably the most important rule of all the rules we have, because almost never do we deal with functions that only have an x on the inside. They almost always have something else on the inside. So when we do the derivative, we're almost always doing the chain rule, right? We don't think of it as a chain rule by name necessarily. We just say derivative of the inside. Okay? So here it is, right here. Here is the chain rule. Okay? Now, this is, you probably remember this from algebra class, this is called a composition of a function, a composite function. We have a function inside of a function. So it's f of g of x. Now, your book will often use this fog, I call it fog notation. F with this open circle g of x, that's the same as f of g of x. F open circle g is another way of writing composite function. I never write it that way, but the book does, and so when you see it, and the AP test, I don't think ever writes it that way, but, okay. So, what do we do? Think about what we just did. Sine was the outer function, like the f. So we did the derivative of sine, cosine. We left the inside alone, so think of it here. We did the derivative of f, the outer function, so that's f prime. We left the g of x alone on the inside, and then we kicked out a derivative of the inside, which would be your g prime. So that's exactly what that statement is saying, and that is called the chain rule. Now, again, I write it this way usually, or this is how I usually say it. We do the derivative of the outer function, we leave the inside alone, and then we multiply. So I got to be careful when I say kick out. When we kick, I noticed on the test, some of you were kicking out a 2, but you put plus 2. When we say kick it out, we're multiplying. Okay? So we multiply by the derivative of the inside. We multiply by the derivative of the inside. Okay? And that is the chain rule. And with those rules right there, the product, the quotient, now the chain rule, we're really close to being able to do the derivative of any type of function there is. There are a couple little things we still have to talk about, but we're a long ways down the road of being able to do these different derivatives. Okay? All right. So, here's an example right here. Okay, let's go through a few examples. See what we have time for here. So we'll do this one together. So what's the outer? So probably the first thing, some of your early homework questions are going to ask you to identify the outer function, identify the inner function, f and g, and maybe write them backwards, g and then f. And so there's going to be some discussion in your homework about outer functions versus inner functions. So what's the outer function here? Something to the 8th, right? Now you're going to hear me say something or stuff a lot, okay? But the outer function is actually x to the 8th. If you don't like x, this is where you saw in those rules yesterday I used u. Just think of u as all this stuff right here. So the outer function is some stuff to the 8th power. Well, so we start with the derivative of the outer function, right? Well, the rule for the outer function is you bring down the 8. What do you do with the stuff? You leave it alone. That's the inside. And then you drop the power to 7. And then you times by the derivative of the stuff on the inside. Now, you need a big set of parentheses there. because we're going to multiply by this stuff on the inside, and there's a plus sign there. So you really got to be careful. This is another place where lack of parentheses really gets people in trouble. Okay? Because now, what's the derivative inside? Well, you got a plus, so you're going to do those separately. So what's the derivative of the 2x? Right. Now, that's actually a chain rule, but I don't think you should think of it as a chain rule. You could think of this, okay, the outer function is e, and the 2x is the inner function. You could think, okay, outside function. We've already done that. We know we kick out a 2. We kick out a 2. Just, that's just the easiest way. It is technically doing the chain rule, but don't worry about it. There. You just, hey, I'm going to kick out 2. Plus 3. On the gateway test. Right? There you go. We're done. Let me put this in red as a warning. Never do this. If on the gateway test you have this, you'll get it wrong. And I don't care how big a time sign you make. I don't care how big you make that dot. That is not right. Why? Order of operations. You're only multiplying by that. You're not multiplying by the plus 3. You're only multiplying by that thing right there. For some reason, people think if they make that dot big, it means all of that. I don't know. There's got to be parentheses around it. There's got to be parentheses. And no matter how many times I say it, some of you are still going to do it. It drives me nuts. I can't believe people still do it. But I'm guessing you will. Maybe this will be the year nobody will do it. All right. Now, on our derivative rules, let me show you this on the derivative rules. Now, we'll take some time tomorrow to write some of this down. But this is why I wrote these derivative rules. As a matter of fact, I'll make this available on the website so you don't have to necessarily write it all down. But this is why I wrote it u to the n. Because we rarely are going to do derivatives of just x to the 8th or x to the 7th. It's going to be some stuff to the 8th, some stuff to the 7th. Okay? So when we talk about the power rule, what is it? It's some stuff raised to the n power. So what do? We bring the n down in front, we leave the stuff alone, we drop the power by 1, and then we tack on the derivative of the stuff, the derivative of the inside. So the u prime you see sticking at the end of all these is just saying the chain rule. If you've got natural log, you usually don't have natural log of x, you've got natural log of some stuff. So the rule for natural log is 1 over that stuff, 1 over the inside, and then times the derivative of the inside, the derivative of the stuff. So that's why you see that u prime tacked onto the end of all those. It's just the derivative of the inside. So we kind of look at our rules in a new way now. We don't think of our rule of sine of x, the derivative is cosine of x. We think of the rule as a derivative of sine of some stuff is cosine of that stuff times the derivative of the inside. The stuff. All right. So let me talk about one more thing here. Oh yeah, this would be a good one. Let's do this one. So, sine squared of x cubed. Here's where that squared thing really gets us in trouble. What does that really mean there?
Sine of x.
This really means sine of x cubed all squared. Why is that important? Because we've got to identify what is our outer function. What's the outer function here? The something squared. And not only that, but our inside has an outer and an inner function, right? So this is 2 levels of chain rule. Now, it's not bad, but let's just go through it. So the derivative, we're going to start with the outside. What's the derivative of something squared? 2, leave the inside stuff alone, to the first power. Times, now I'm going to put a big set of parentheses, times, now what I'm set to do is just now do the derivative of the inside, right? Well, so now I'm going to do that in black. So now I'm just going to do the derivative of this. Well, it's an outside and an inside, right? So we do the derivative of the outside, which would be cosine, leave the x cubed alone, but then the derivative, I don't have enough colors, green. And then the derivative of that inside, which is 3x squared. Oh, that's all. Sure. Now, this was a nice one because everything is just multiplied. There's no plus signs, which really can mess you up. You really got to be careful with parentheses. Now, this would not be good enough to leave. since these are all things that are multiplied in this power, we don't have to worry about since it's a 1, we need to put this together. See this 2 and this 3? That makes 6. You need to put that together. Now the rest of it, I don't care what order you write it. Now it's just about rearranging. Probably bring the x squared out in front, be nice, and then cosine x cubed. So there would be a little bit of simplifying there. That 2 and that 3 would need to come together as a 6. But a lot of times you don't have to do anything like that on these. But sometimes there's a little bit left to do. Okay? All right, without doing it, I'm looking at this next one. Now you're going to bring the 3 down in front. You're going to leave the inside alone. You're going to drop that 3 to a 2. And then when you times the derivative of the inside, what are you doing? You're going to have a whole quotient rule to do, right? So the derivative of the inside ends up being a quotient rule. So that'll be out there, right? So you can have something like that. And then finally, the last thing I would comment on is there'll be some more of these kind of questions. Is h increasing at 2? Well, that's like asking, is h prime of 2 positive? Before you can find h prime of 2, you got to find h prime of x. Well, here's h of x, so here would be h prime of x. So very much like you did with the product and quotient rule. You write out h prime of x, which is just your chain rule. Now you plug a 2 in. Now you plug a 2 in everywhere, and you find out if you get a positive, right? Or, what are the stationary points? Well, you do the derivative, set it equal to 0, and try to solve that way, whatever. Okay, so all those things we learned come into play there. Okay, all right, so the next line on the assignment sheet in section 3.2 is what you have to do. And then, starting tomorrow, we still have a few new little things to do, but I'm going to give you a website where you can do some practice. Friday all day is going to be practice and review. Some of it together, some on your own. And then Monday, pretty much all day, is practice and review and just final practice, get ready for Tuesday. Okay?
All that reviewing, we still don't pass on.